All right, so discrete random variables. Random variable is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. They are typically denoted by using capital letters. All right, discrete random variable has either a finite or countable number of values. They can be counted on a number line with space between each point. And here you just have a diagram of what they mean by that. If they were to ask in my math lab. Continuous random variable has infinitely many values and can be plotted on a line in uninterrupted fashion. So in other words, the right answer or the domain of the values that you're using could be 0, 1, or anything in between, 0.1, 0.5, all that stuff would actually apply in that type of variable. All right. So discrete or continuous. Now, I already have the words down there, but we can still walk through and talk through it. It says the number of A's earned in a section of statistics with 15 students enrolled. So remember, discrete are, if you go back to the definition, discrete random variable is a finite or countable number of values. So if you can actually count it, put a number on it, it's considered discrete. So we're talking about the number of A's earned in a section of statistics with 15 students. If 5 people earned A, 5 people earned A, and you can actually count that. You can actually put a number on it. If you can actually count it or put a number on it, it's considered discrete. Now, the next one, the weight of a sandwich at the deli. If you're measuring something wherein it gives room for my measurement to be correct and your measurement to be correct. And what I mean by that is if I have a scale and my scale is a little more precise than your scale, both of our answers would be correct. Um, if mine go down to the hundredth place, yours only go to the 10th place. That doesn't make your answer wrong and my answer, right. Both of our answers are right. And so that's what we mean by it's a continuous variable. There are multiple answers for the weight of that sandwich, and that will be considered correct. All right. The number of cars that pass through a McDonald's drive-through in the next hour. So you would just count the cars. If you have 5 cars, you have 5 cars. If you have 6 cars, you have 6 cars. You can actually put a number on it. There's no such thing as 6.1 of a car. So that would be discrete. And then D, the speed of the car that passes a state trooper. Once again, we're talking about measurement. And so that would be continuous. All right, questions. All right. Probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. All right, two rules, I believe it's two, yep. Two rules for a discrete probability distribution. Here we have sigma p of x is equal to 1, so that means you add up all the probabilities, it's supposed to equal to 1. And then rule 2, all of your probabilities are between 0 and 1 inclusive. Mm-hmm. So once again, the two rules that they give us that has to be the case for a discrete probability distribution. All of your probabilities have to add up to 1, and then each one of them have to be between 0 and 1, which are rules that we have touched on before. So here they give us 3, and it says which of the following is a discrete probability distribution.
Hey, Professor.
Mm-hmm.
Go up to where it just is the second one. I just didn't get that one real quick.
So right there.
Yep.
Okay.
Yep, that one right. All right, thank you. I got it.
Not a problem, not a problem. So here we have three possible discrete probability distributions. So I'll give you guys a chance to write those down, and then we'll look and see which ones actually, which one or ones actually fit discrete probability distribution according to the rules that they gave us. All right. So looking at the first one, we have the probability of 1 is 0.2, probability of 2 is 0.35, probability of 3 is 0.12, probability of 4, 0.4, and then probability of 5 of negative 0.07. So when we look at A, that fails rule 2. Look at the probability of 5. So remember that our probabilities have to be in between 0 and 1. So that fails rule 2. Looking at B, we have 0.2, 0.25, 0.1, 0.14, and 0.49. So if you were to add those together, we get 0.118, well, 1.18, and that fails rule 1. Remember, all of your probabilities, when you add them together, it's supposed to give you 1. So anything less than that or more than that, then that fails rule 1. All right, so before we go to see if C fits, any questions on A and B? So A had that negative 0.07, so that fails rule 2. And then B, when you add up all of your probabilities, it adds up to 1.18, and that fails rule 1. All right, let's go up. All right, so looking at C, go back. It all of our probabilities are in between. Oh, didn't mean to put that one. Still have my eraser up. So all of our probabilities are between 0 and 1, so that's fine. So rule 2 fits, and then if you add them all together, see that we get 1. And so C does represent a discrete probability distribution because it satisfies both rules. I'll write that down. All right. Any questions? I'm gonna scroll up. All right. Okay. So here I was just saying that if my math lab asks for the mean of discrete random variable or the standard deviation of discrete random variable, then do like we mentioned before. If you were to Google either one of these, um, first one or two websites will be instrumental in helping you to find that. I know we had problems like that before in the past. Um, you know, so just in case something didn't change, I'm not asking you to be able to do that by hand. All you have to do is Google one of those, whichever one they're asking you to find, and type in the information, and just find something that's reliable. Like I mentioned before, easycalculation.com is always a good one for it. But yep, if you were to Google those and then type in the data that they gave you, then you should be good to go. All right, and then if you have any questions with that or can't find something that's reliable to help you to find the answer, um, then let me know, and then we'll make sure that you're straight on that. Because if I'm not mistaken, looking at the next section, they don't even all they do is ask for it in this section. Then we don't do anything with the application of it later on. So, yeah. So I don't require anything of you if my math lab asks you for it, other than just making sure you have something reliable that will be able to help you to find it. All right. Questions, questions, questions. All right. So that's six. Okay. So that's 6-1. Like I said, I'm trying to, drag it out a little bit, give you guys a chance to get into 6-1, 6-2, see if you have any questions, see if you have any issues. When we go, I got it right here. Yep. So remember that test 3 is going to have 5-1 through 5-4, 6-1, and 6-2 on it. So that's what's going to be on this test that we're talking about doing next Wednesday. All right. So we easily could have done 6-1 and 6-2 today, but I'm just doing 6-1 and we'll do 6-2 on next class. All right. Any questions before we close?
Okay, you said the test is on March 3rd.
Yes, next Wednesday.
Okay. Okay.
All right. Anybody else before we get out of here? Everybody good? If you have any questions on anything leading up to this point, everybody. Okay. So next class will be short again. We're just going to do 6-2. Um, so if you have any questions that you want to get answered on next class, you can always ask them after we do 6-2. And then once again, we'll have this review day on Monday of next week. And then we'll look to do the test on next Wednesday. All right. So if you guys are good, I'm good. I will see you on next class. Have a good day.